Here's a trick to the previous half-life problem. So if you're given a half-life problem where some element it has a half-life of some number, in this case 30 years, and you ask how long does it decay to some later smaller amount, some percentage of the initial value, then the time required for that to take place is equal to the negative of the half-life, which is 30, times the natural log of the percent left over divided by 0.693. And so let's go ahead and solve this, and then we'll see how this equation came about. So we have negative, the half-life is 30, so plug that in here. And then times the natural log of the percent left over. Well, there's 20% of its initial amount, so there's 20% left over. So this is 0.2 divided by 0.693. And if you type this into your calculator, you will see that this is approximately equal to 70 years. Okay, now, a couple of things to make note of. This percent left over needs to be in a decimal value, so 70% is equal to 0.7, 80% is 0.8, 20% is 0.2, and so on. Next thing is the reason this negative sign is here is because the natural log of a fraction of some number less than 1, natural log of 0.2 is going to give a negative number again. So this negative is canceling that negative to give positive time, right? Because time has to be a positive quantity. Okay, next thing to make note of. If your professor asks you the question in such a way that there's 20% left over, then that will plug right into this. You'll put 0.2 right here. But if the question says something like this, if the amount decays by 80%, you don't put 0.8 in there because it decayed by 80%. You need the percent left over to go in here. So if it decayed by 80%, that means 80% went away. You're left with 20%. So this needs to be the amount left over, and you just have to look at the wording of the question for that. But that's a couple of things to be aware of. To see where this came from, take a look at this k. This k is equal to, if you notice, this is the natural log of 0.5, so this is the natural log 0.5, and then this is the half-life, so this is divided by the negative of the half-life. So this is equal to negative 0.693 divided by negative of the half-life, and the negatives cancel and we get 0.693 divided by the half-life. Okay, then coming to here, this term right here, this 0.0231, is this. So we could write this. We could say and this number here, negative 1.609, is the natural log of the percent left over. So this is the natural log of the percent left over equals negative this 0.693 divided by the half-life, 0.693 divided by the half-life times t. See this t here? And then solve for t, and we get that t is equal to, see the negative is going to have to come over, right? So we're going to multiply times negative the half-life on both sides. So multiply times negative of the half-life, and then negative of the half-life, and then t is equal to negative the half-life times the natural log of the percent left over, percent left we'll just say, divided by, now we have to get this 0.693 over, so we divide by 0.693 on both sides. And look at that. This is the same as this. Right, well, really, I just derived the generalized formula, so this is the same as this. So Okay, use it. It is useful. I'm going to step aside and give you a clear screenshot. Check it out. Verify for yourself that it works. See you later.